Once again, thanks again, Naman, for introducing me, and we'll be talking about chaos engineering today. And before I talk about chaos engineering, just a quick intro about myself. My name is Prithvi. I'm 23 years old. I'm based out of Bhubaneswar, and I've been working on this project called Litmus Chaos since the last 2.5 years, since I was in college and now post college as well. It was part of Maya Data. We were building data there, and then the project itself, it was just a part-time project. It was just like we thought it's for the interns. We had no clue that if this project will become something or it will actually grow, but it grew into a company eventually. And that's been the journey, and this was acquired by Harness this year. And now I'm part of Harness. I've been organizing events, Chaos Carnival, that's a flagship chaos engineering event, Kubernetes Community Days, Chennai, Bangalore, and every last Thursday of the month, we also organize chaos engineering meetups. A lot of students. I think a lot of the population here is a student population, and they are pretty interested in contributing, becoming a part of the community, taking interest in actually leading, and then getting a job or maybe becoming maintainers to the open source projects. So that's why we organize chaos engineering meetups, and I hope to see you all one day joining these meetups as well. So before I get started with my talk, when I joined here, I saw someone, I think Jyoti, she was talking about downtimes and outages and why outages are important. So before I just get started with my talk, I just want to show of hands who all tried purchasing something in the Big Billion Days or the Flipkart Great Amazon Festival. And I hope everyone faced some sort of an outage and they were not able to purchase their favorite mobile phones or something they wanted to purchase because the website went down. And that's what began the concept of chaos engineering. Here are some outages that we'll be talking about. I mean, Great Indian Festival, the Amazon sales or Big Billion Day sales, or even a new movie or a series that comes out on Netflix or Amazon Prime. We see that there's a possible outage, either the system goes down or the website goes down, and that's what Netflix coined in terms of chaos engineering when they brought in this concept back in 2012, where they wanted to scale, they wanted to understand what can happen when an outage happens, and they started with an open source project called Chaos Monkey, which was just to delete some pods in production and then visualize what will happen when a real life scenario happens. And similarly, these outages have caused havoc, have actually caused losses of billions and millions of dollars for these companies. Let's say you talk about from Meta, the Meta Group, Facebook, Instagram, WhatsApp, to every other company today needs chaos engineering because an outage can happen anytime. It's like Murphy's law: what has to go wrong will go wrong, right? So that's where the concept of chaos engineering came into play, where each and every company, let's say HBO, Hotstar, all these folks have started moving towards this concept, and that was only to understand what sort of a chaotic condition can happen in real life. Where can a production system go down? Where can users scale up in a minute and something can go down? And that is why these are some outages that happened in real life scenarios, and here are some explanations on what actually went down. An outage can happen with AWS, Atlassian, Delta Airlines. These are some examples which faced outages, and as you can see, even Facebook recently had an outage last year, and the share price of Facebook fell down nearly 5%, which is a lot of money. Because I think last year or before that, I knew that Mark Zuckerberg is like somewhere in the top elite list of rich people, and then since a couple of outages, we have seen him dropping down. But I would say that's the reason behind the drop. But once again, these outages have not just caused loss of money, but they have also led to loss of confidence amongst employees, amongst your customers. There's legal action that is being taken, and you can see these are the actual cost of downtimes and outages that have happened over the years, who have moved to various architectures. Let's say we were living in the monolithic world, but now we are shifting to the microservices architecture. And every other day there's something or the other being developed. Applications are dynamic today, and you can't just stick to one sort of thought process. I mean, there's performance testing, there's integration testing, and there's so much more. But no one's actually thinking about what can happen when the system actually goes into production, right? And that is where chaos engineering came into play, where from one instance we talked about just deleting a pod to everything, to attacking your database layer, to attacking your application layer. You need to continuously test what can go down, and you need to induce these faults carefully, because it's a very tedious sort of a process. Everyone's not ready for chaos. People are scared, actually. Like, being a part of this community for 2.5 years now, people have been scared because either they don't have the budget or they don't know what will go wrong in production. And there's a testing mistake that can happen any day or every day. So that's what we'll be talking about, and then we'll be talking about the open source project Litmus. So as you can see the agenda, we'll just cover resilience in a short while, and then we'll talk about chaos engineering, how you can chaos engineer. We'll introduce Litmus, the open source project. I did not prepare a demo because I thought it would be a hodgepodge for me, so I just have put out screenshots of the demo, and then we'll talk about how you can contribute and you can be a part of the project as well. So let's take a look at examples of what can go wrong in a Kubernetes ecosystem. As you can see, there are 3 examples of what goes wrong. A pod is evicted from a node, there's a memory leak in a container, or a node goes to a not ready state. And just in case such sort of conditions happen, if the system can regain its original state, or it can go back to its steady state as it was, then the system is resilient, or there's a weakness, or there's a possibility of a weakness that is found, and you need to mitigate that. So, I mean, resilience is nothing but the ability of a system to withstand what can go wrong and mitigate itself, or stands back to the steady state conditions in spite of that vulnerability. And that is what brought in the concept of chaos engineering, where let's just take a closer look at chaos engineering. Chaos engineering is nothing but inducing a fault deliberately into the system. You are inducing a pod delete, or a node kill, or a memory leak, or something deliberately into the system to get to know what can happen when such sort of a chaotic condition happens in real life. And it's basically the ability of your system. I mean, once your systems are resilient, then you continuously test, because chaos engineering is about continuous testing. It's not about once you validate and let it go, but it's more like it's a continuous process where something or the other might go wrong in your system. So here is an example of a pyramid. That's your application. Your application is in the form of a pyramid, and that's just the topmost part of the pyramid itself. That's the tiniest pyramid, I would say, in this mega pyramid, because there are multiple layers to your application. There's your application, and then there are other dependencies, let's say Kubernetes dependencies, and then there are cloud native services, just like your Prometheus, or your cloud native databases, your CoreDNS, your Envoy. And then there are your Kubernetes services, and eventually there's your platform layer. And each and every layer is open to vulnerabilities. There's something that can go wrong in each and every layer, and you need to induce a fault in each and every layer to validate what can go wrong in your system, what can happen to your system. So that's why chaos engineering was necessary, because it goes down to each and every layer. It's not just about your application, which can be mitigated with other forms of testing, but it tests and validates each layer in a continuous process. So we'll see how that's done. But as I said, once again, too many other applications affect the resiliency of your system, and they are dynamic in nature. They are changing very often, and you need to validate constantly. So as you can see, again, I saw a lot of people interested in DevOps, and there was a lot of interest, and that's where chaos engineering also started off as a practice for SREs. It was basically more on the ops side, and the idea was to continuously test, activate the feedback loop, because we believe in the chaos first principle. That's why wait for your systems to go down. Why not test before it goes into production? So but it's shifted from the SRE practice right now. It's more of become practice which everyone is looking at. today being a part of the community since the last 1 year. Even developers have started using chaos. They have started inducing faults in their systems. And if you are versed with the term SLOs, service level objectives, that's a term popularly used by SREs. So once you identify how your system is in a steady state, how it's behaving normally, you build a hypothesis around it. You hypothesize. You create a test suite. Basically, the scenarios that you want to run. Let's say you want to run a pod network loss. You want to run a node kill. You want to delete some pods. Once that's done, you introduce the fault. Your SLOs are basically ensuring that your system is resilient. And if they are continuing to be met, yes, your system is resilient, and no, then it moves on as a loop. Once a weakness is found, we go back introducing a fault, or we go back mitigating the same, and then once again we ensure if the SLOs are continuing to be met or not. That's the basic way of running chaos engineering, but it can be harmful as well. There's a lot of harm that can happen. Your systems can go down for longer. There can be huge losses as well, and that's why the eventual goal is to minimize the blast radius. Whichever application you are targeting, you need to ensure that you don't burn a lot of cost behind it, or you don't burn a lot of experiments that can lead to other conditions. And that's why organizing a game day is pretty important. Again, this is how it's run. This is the loop. You select the experiments, you run them, you observe. Again, observability, I think a lot of people have talked about. And there are so many platforms today: Dynatrace, Datadog, Grafana. If you are versed with observability practices, then you monitor what's going down when your systems are normal. There's a particular graph, and when your systems go down, you can see the spike in the graph. Either it goes down or it goes up. And then these learnings are basically used to create such data points where your systems can stand still. And that's why I think I have a complaint against even Flipkart, that in spite of being such a huge giant, being part of the Walmart company, how can systems go down in basic scaling practices? But again, this is a practice which is new. Netflix brought it in 2012. Amazon has come up with FIS, the AWS FIS. They are experiencing such needs, and then slowly, I'll name some huge giants. There's Adidas, there's Accenture, HCL, Nike, Expedia. Everyone is today focusing towards chaos engineering, and it's actually crossed the early majority adoption, and today a lot of people are adopting the same practice. So as you can see how it's typically done in the form of game days. The game day is nothing but creating a test suite according to your application and running the set of experiments. As of now, it's rarely integrated into the CI/CD, and as I said, it was just a practice for SREs. So typically, the practice, as you can see, is outdated. It's old. People are not focusing on automating or moving towards automation, but this typical practice is changing today. The eventual goal is to automate your experiments, make sure that there's a test suite created which runs according to a schedule. There's a particular test suite that you have. There are teams that are running the same. So the typical practice is changing, and that's what the good news is about chaos engineering, because a lot of people, just like you, just like everyone out there, are becoming a part of this community. But before I talk about Litmus Chaos, how many of you out here are actually well versed with CNCF, or Cloud Native Computing Foundation? I think Kubernetes was the first project. It was donated by Google to the Cloud Native Computing Foundation, and today it hosts so many projects. If I just open the landscape, you can see how many companies are part of the CNCF landscape and how many projects are actually part of the CNCF landscape. There are so many popular projects like Orgo, Flux, Kubernetes, Helm. Even Istio became part of CNCF just a couple of days ago. Linkerd. So these projects, I'll just give you an intro. These are open source projects which are licensed and hosted on the CNCF platform. Any one of you can contribute to the project, and students or people like you have become maintainers. They become a part of the Linux Foundation. They contribute. The GSOC program itself hosts a lot of CNCF projects and invites mentees. I have led a lot of mentorship programs. A lot of mentees have come in. They have learned a lot. They have joined massive companies, big companies around the globe. And that's the opportunity for you that CNCF provides. You can come in. You can come in with coding contributions or non-code contributions as well to the documentation, to the websites, to something that helps the project, and slowly you can become core contributors and maintainers to the project. And one of them is Litmus. It's a CNCF incubating project. Once again, we created it just to test another CNCF project, and now it's come so far. It's a community. It's a massive community. And that's what Litmus is again about, an open source project to reduce faults, to curate chaos engineering. It's a chaos engineering tool, and a CNCF incubating project is the second level of the project. You would become a CNCF project by becoming a sandbox project, and once you have a level of adopters, once you have a level of contributors, you can become an incubating project, and it has its own perks. If you are a contributor to the project, you can come in, conduct on-demand webinars, you can write blogs, and you will be a popular face in the community itself, because CNCF is the next big thing. A lot of people talk about AI, ML and other practices, but CNCF projects are something that are being adopted by each and every company around the world. Companies like Apple, Spotify are investing heavily in it. So it's just another opportunity for everyone out here to make a name for themselves by contributing. So that's what Litmus Chaos is. I think I'm the biggest brand ambassador for the project, and I have been leading this project. You can see just some stats. It started in 2017. It's adopted by many companies. I have just listed a few out here. And the Stable Platform 2.0 released last year. So now it's having an amazing UI. You can curate chaos easily. I'll just take you through the UI as well. But as you can see, there's millions of installations that have already taken place, and there are so many more adopters that are coming up, and a few popular ones are obviously Adidas, AB, Bev, FIS, Wipro, etc. So let's just see where you can use chaos engineering or Litmus Chaos itself. You can use it anywhere. It's not just about production, but in your CI/CD, in your pre-staging environments, in your staging environments, in your pre-production systems, in your production systems. Chaos can come in anywhere, and that's the beauty of Litmus. And you can write your own experiments as well. I mean, we created a chaos hub, which is a marketplace where you get experiments on Kubernetes, VMs. You can target your GCP, AWS, anything, but you can write your own experiments as well. So I think there was a talk about Hacktoberfest, which kicked off the event, and Hacktoberfest has already started. I think yesterday it started, and it invites contributions. We have been taking part in Hacktoberfest since the last 4 years. So you can write your own experiments as well using the SDK. So if you know, a little bit of Docker, containers, or any DevOps practices, and then you have started writing something on Python or Go, then this is the place for you. You can write your own experiments in Python, Go, or Ansible, and you can contribute back to the community, which again is being used by so many folks. So these are the main components. So one is the Chaos Center, that's the UI, that's a single source of truth, and then the Chaos Agent, which is basically the target cluster. So there has to be one Chaos Agent that's connected with the UI of the project, so that you can start inducing the faults. So before we move on to the demo, you can see what's exciting about Litmus. Any one of you are well versed with the term GitOps? Another popular term. I'm not sure if you are having talks on GitOps, but if you move around the country, if you see what's becoming popular, it's GitOps. That's another popular topic that's there. And then GitOps, obviously, Litmus is the only project which has a GitOps functionality. So basically, you can make changes to the UI, or you make changes to the artifacts, and that's synced. And GitOps helps you scale. So if any one of you has heard about Orgo or such projects, then I'm sure that you have a lot of idea on GitOps as well. And there's a Chaos Hub. As I said, it's a marketplace that's also one of a kind. So there are only a few chaos engineering projects out there. There's Litmus, there's Gremlin, that's I think an enterprise tool. But on open source side, there's Chaos Mesh, Chaos Toolkit, and Litmus Chaos, as well as Chaos Blade. These are the 4 popular projects. And these functionalities are one of a kind. You can schedule your experiments. When do you want to run them? When do you want to attack your systems? There's monitoring and observability. There's more controlled chaos. There's, so much more. And resilience score as well. You want to calculate how resilient your systems are currently, and if they are 100% resilient or not, or if there's something that has gone wrong. And that's what's exciting about this tool. That it's community driven, and it's got so much more. So these are some stats. As you can see, the growth has been exponential, and it has reached a point where it keeps on growing. When it started off, it was absolutely nothing. People laughed off at us, but that's been the journey where this became an incubating project, and it's not really easy to become an incubating project today in the CNCF. Just some stats once again, but we'll quickly move on to the demo itself. But before that, as you can see, if you have used Kubernetes ever, I did not cover a lot on Kubernetes, but if you have used Kubernetes ever, that's what it holds. These are some examples of failures that can happen. There can be a pod failure, there can be a container kill, there are pod level experiments, there's a node level chaos that can happen, there's a network layer level chaos. So these are examples of the different levels of chaos that can take place. These are the variety of experiments that are out there in the Chaos Hub. And this is how the Chaos Hub looks. So we are obviously in a Google Cloud conference, and as you can see, there's even for GCP, there are chaos experiments that are available. You can have a GCP VM instance top, you can have a GCP VM disk loss, and a GCP VM instance top by label, and then a GCP VM disk loss by label. So these are the 4 popular experiments that are available on the Chaos Hub for GCP. And then obviously it started off as a Kubernetes project and widened into non-Kubernetes scenarios as well, where the idea was to attack monoliths, the idea was to attack your VMs, bare metal. So that's what is available on the Chaos Hub, and you can just go through the Chaos Hub. It's hub.litmuschaos.io. So you can find all the experiments that are readily available. And as you can see, it laid foundations for cloud native chaos engineering. So until now, we were talking about chaos engineering, but we laid the cloud native principles as well, where obviously these factors are pretty important. It has to be open source. There has to be things available for the community. There's open observability, where we just pull in the Prometheus metrics and we visualize them. The analytics was available with the UI as well. And similarly, GitOps and OpenAPI and lifecycle management make up for the foundations or what founded the layers of cloud native chaos engineering. So moving on, I just have a quick demo for you all. We talked about the Flipkart website. So we'll similarly take the online booting that's available on Google Cloud. Just like there's a Bank of Anthos application, there's an online boutique app. These are available on Google Cloud itself, and as you can see, this is a sample app that we have taken, and it's an online e-commerce website which hosts various products. This is the product catalog in front of you. There's a cart, there's currency exchange that you can change, and then some banner that you display on an offer basically. And our idea is here to see what sort of a fault can happen in this sort of a website, in this online boutique page. So the goal eventually is to curate a chaos experiment so that this website fails. That's the goal. And now moving on, you can see this. These are our clusters. This is our cluster and these are our workloads. Again, we have taken a GKE cluster, and there's Litmus that's running, and then there's this website that's running on the cluster. So these are the workloads. As you can see, there's the Litmus front end, the Litmus server, the auth server, and then there's the catalog. So the card server, these are the services that are running: the ad service, the card service, and there's the shipping service, there's the catalog and all this is running, and we try and run a pod delete experiment. So a pod delete is the simplest Kubernetes pod that can be created. And we run a pod delete, as you can see. This is after the success. I have put the screenshot out here on what are the workloads that are running. And before that, we just see the UI of the platform. So as you can see, this is the UI of the platform where you are welcome. It's admin by default. And the chaos scenarios are basically the multiple scenarios that you run. So you can run them in series or parallel. And you can run all these experiments together. So if you want to run a pod delete, pod network loss, node kill together, then that becomes a scenario. That's basically what a scenario is. And it just shows which cluster is running. So there's a self agent that's running on the chaos delegate. The hub is basically, you can create your own hub. So I'll give you an example. A company like Dream11, they created their own hub. So if someone of you has used Dream11 already, you see that before the match begins, there's a huge rush to place, create your team or place your bet out there. And that is where a possible outage can happen. You can lose your money, you can, either not create a team. And that's why they created their own tools, their own set of experiments, and they basically put out that in the community as well. So the Chaos Hub is available for you to put out your own experiments. You can pull the experiments from the hub, and that's how you run your scenarios. So as you can see, the delegate shows that there's a self agent running on your cluster, and if there are multiple agents, there's another agent that's running. There's another target agent maybe you're running. That's also displayed on the Chaos delegate side as well, and that's how the Chaos experiment runs. So as you can see, we are trying to delete the catalog. So there's a catalog delete that's happening. You install your Chaos experiments first, and then the pod delete goes out, and the logs are displayed for you for your help. So once that's done, maybe you can visualize that as part of analytics as well. You can see how many runs you have done, how many Chaos experiments you have run. Then we just ran one scenario and it was successful, but things can go wrong, it can fail as well. It can be in the running state. You can run multiple experiments, you can run them daily, monthly. So all this can be analyzed as part of analytics, and then you can compare the scenarios, which scenario was successful or which wasn't. So any of you, if you're already part of companies, if you're part of SRE teams, then this is a practice that you might just want to pitch to your SRE leaders or performance leaders. And as you can see, the system went down. We just conducted a pod delete and we cannot see the product catalog anymore. There's a 500 internal server error, and that simply goes out. There's a 404 error, or there's some error that usually happens on these websites. You cannot conduct your payment. For, let's say, if we take the example of banking, your balance is not displayed, or there's a wrong withdrawal that's displayed on your account. So these are the examples, and this is what goes wrong when we delete a pod. There's a server error, and we run it for 60 seconds, and once that's done, it comes back. It comes back to the original state, and we are able to analyze and take care of things that went wrong with the system. So this is the future roadmap. Again, the idea is to create more non-Kubernetes scenarios, more application-specific chaos, improve the SDK so that there are so many other people who want to write experiments become a part of this. So we want to improve that, and obviously more chaos types and improve observability are our goals. I did not go into the depth of it because I see there are a lot of people who are beginning with this topic. But again, how you can contribute is, I think, one of the main parts. You can contribute to the UI, you can contribute to the Litmus Go, you can contribute to the website. There are all kinds of contributions that we welcome. So if any one of you are already on Slack, then I would urge you to join the Kubernetes Slack. That's slack.kts.io. And then you join the Litmus channel, where you can find me or you can connect with me on LinkedIn, as I said. Ask me how you can contribute, and I'm sure that I would love to help you all contributing, becoming a part of the community, using the same. And as you can see, these are the places where you can contribute to. There's a meetup group. It's having, I think, around 2,000 folks. You can join for the meetup. You can join the Slack. You can just raise your issues on GitHub. Hacktoberfest is going on. There are a few issues for Hacktoberfest. You can check them out. And other than that, anywhere else, if you want to reach out, tag me on Twitter or something, you can reach out as well. And as I said, we are part of the LFX mentorship program, the GSOC program, and there's, I think, a GitHub externship as well that took place last year, and we were part of that as well. So any of you interested, wanting to learn and then gain something out of it, stipend, certification and everything, you can be a part of it as well. And lastly, there's a certification, Harness Chaos Engineering, that we are providing. I've not mentioned it here, but any of you, you can just Google the same. You can get your certification and put it out on LinkedIn. There's a badge that we are providing as well. So that's a very good starter. That's an early starter for everyone who wants to learn chaos engineering, and that will help you again become a part of this community. So with this, I have come to the end of my talk, and thank you so much.